So hello everyone. I'm Emmanuelle Autret from the French Marine Institute, IFREMER. I'm a researcher focusing on physical oceanography and remote sensing. I'm involved in the CMEMS L3 and L4 production. It's a collaborative work done with Jeff Piollet. I'm also involved in the Trishna mission. I'm in the Trishna mission science team, and I lead the coastal and inland waters subgroup in this science team. So during the week, we saw several presentations highlighting the need for ultra high resolution observations, especially near the coast. So, for example, with a presentation from Grishna and also from Nandini on the use of SST as a proxy to monitor algal bloom, or also in the presentation on the coral reef, the coral bleaching monitoring. We also saw during the week several presentations on the upcoming missions, the Trishna mission, the LSTM mission also. And we had also heard about the future SBG mission from NASA. So I think so as a since I'm involved in the Trishna science team, for example, CNES often ask me details on uncertainties, on user requirements, for example, to define the acquisition mask, on algorithms, on cloud masking method, etc. If I can't answer, I ask Chris Merchant, Jacob, or other GRIS people. So maybe we could create a group in the GRIS community. So finally, a task team gathering agencies or producers or future producers of these high resolution SST products, and also experts in algorithms, in SST retrieval, so, or in cloud masking, etc. So I think that, for example, very high observation, so at 100-meter resolution, I've been available since decades with the Landsat mission. Since the first observations was available in 1984, and there is no dedicated SST product from this observation, from this mission. We can't find publications and papers using those observations, but each paper started from L1 observations, for example, from Landsat, so and tried to estimate SST product to be able to do the study. And so the radiometric performance was not so good, the temporal resolution also, but I think we can do something with this kind of observations. And in the frame of all the upcoming missions, we should do something to prepare the user community to use this kind of observations, and to also do a link between agencies involving in those future missions and the user community represented in the GHRSST, for example. So can you put the slides, please? Yes. No. Yes. Okay, so maybe it's beyond this panel, but I can't be here at the closing session, for example. So we would like to propose ultra high resolution coastal SST task team involving agencies, users, experts. The objective is to address the specific challenges of ultra high resolution observations over coastal waters. We could also add inland waters, maybe. So the missions of this task team will focus on existing missions and also upcoming missions. The issues to be addressed can be the following. So the geolocation problems, the cloud masking method, and also other masking techniques to discriminate between water, land, or ask pixels. How to cope with tides, and also in intertidal zone, and how to classify those pixels, which algorithms or flag. We saw a presentation from Chris Merchant yesterday, also dealing with the noise problem. In my presentation yesterday, I also shown some issues on the ecostress data, for example, with stripping noise and also radiometric noise. How to cope with aerosols. What can be ancillary data or auxiliary data in SST retrievers, for example, or in the flagging methods. For example, from Trishna, we could have information on, and we could have AOD products, but maybe it's not possible for other missions. And an important issue is also the collection of coastal data, in situ data for validation, and how to identify them, how to share them, and which observations can be considered as FRM for coastal products. I think the format is also very important. And the last point concerns the tools. The volume of the data will be huge. And if we want users can are able to use this data, we have to maybe facilitate the access and the tools. When in my presentation yesterday, for example, it was written that for eco-stress, for 5 years of eco-stress, it represents several terabyte of data. So, okay, that's it. Thank you.
Thank you very much, Emmanuelle. Yeah, I think there's definitely a clear need for the task team, and it's very welcome that you're starting to organise it. And I think I don't know what the process, Chiara, but whether we need to sort of have an agreement or just follow up after the meeting with Chiara on the organisation aspects. I think. I don't know if you want to comment on that, Chiara.
There is a procedure for starting a task team. So I will get in touch with Emmanuelle, and if Emmanuelle is willing to take up the chair, then I will share with her the rules that we need to follow, and then we will try to set this up as soon as possible. And also this goes with the other proposals that I've heard today. So I'm trying to take notes for myself of which one is coming up next. But thank you for this. I will get in touch.
Okay, thank you. Jakob?
Yes, good morning, everyone. So I'm Jakob Høyer from the Danish Meteorological Institute, and it might be a theme here, but I'm also a physical oceanographer, so that you need to be that to be in the panel, maybe. But anyway, I'm working with, well, I'm coming from DMI, and we are, of course, interested in very much in Arctic conditions and what's going on in the Arctic and in the waters around Greenland. So I'm coming from a unit with dealing with satellites and the Arctic, but also some observations in the North Sea, Baltic Sea, and in the southern Danish areas, as we call them. And well, a few thoughts about priorities. Maybe picking up on Emmanuelle's. I think the high resolution missions. I think that's a really nice topic, and we'll for sure support that. Our task team on that. It's evident that it's going towards coastal services in Europe. I mean, within the Copernicus services, we are now starting to build up the Copernicus coastal services, and there will be a demand for these products, and then again increased knowledge and information about the validation and the performance of the products in the coastal zones. So I think that's for sure something we should have as Christo, as a community, should have some focus on. And also, I guess it's also having a task team like this it's also a matter of we have a mechanism for maybe interacting more with the space agencies. It's really nice to be here and to that Stefan Isa is here, and we have the whole ISRO group and around Tristan here. But also, I mean, there might be other space agencies, other missions that want to have a sort of address some issues and want to ask questions to the international community, and that could be a way to a mechanism to take up these questions and facilitate that. So I think it's an important it's an important role that this task team can play, both internally at GRIS, but also sort of facilitating the communication and the impact with and the discussion with the agencies. I know you're doing your bit, and that's great with Tristan, but I think that could improve for the other agencies and help there. All right, then. Well, related to that, but I think we'll come back to that. It's about the updating of the GDS. That will be probably in the next session. I mean, we also have to accommodate the new missions and the new requirements and new data and data types and so on. If GRIST wants to be relevant and stay relevant, we have to make some update to the GDS. Consider at least how to integrate the high resolution data the ice surface temperatures, for instance, as in a homogeneous way, so that it can be included, because otherwise the evolution would go in other directions outside or around GHRSST. And then, from our own backyard, it's I think it's about the Arctic and consistency. I think that the key word here is consistency in the Arctic, and as we see it, and that's both in terms of the different surface temperature products. We have infrared, we have microwave sea surface temperature. How to reconcile those? They have different error characteristics. It's about this sea surface temperature and ice surface temperature, where we can see a huge potential. We already demonstrated our potential in improving the estimations of the Arctic amplification, and in particular in the light of the recent changes going on in the Antarctic. I think the polar regions become even more important as we see it, at least. Yeah, so I think, last point is just about the marine heat waves. I think that was really interesting, the session we had this week. I think, and we should continue with that. I think maybe a more general topic we could consider is sort of having some focus on the indicators, and marine heat wave is just one of them, as I see it. But it's a topic that if we are discussing and working together on developing marine indicators or ocean indicators, then we can see we have a much better impact. It will increase the societal impact of our products. I mean, it's much more relevant for users to have it when we put it in the context of indicators than maybe just data. At least a lot of they will expand the user database. So I think that might be something to look into in a more overall framework.